Despite the fact that we live in the universe, there is still a lot we don't know about it. Even with such limited evidence, there are many of scientific hypotheses about space and time that can explain our galaxy's greatest mysteries. However, not all of them are pleasant. Some of them are horrifying, while others emphasize how alone we are out in this abyss we call space. We get what you're thinking. They're only hypotheses, right? Why should I be scared? Well, these scientific theories about the universe were developed by some of the most brilliant minds in the field of cosmology and physics. These people know what they're talking about, and what they're talking about isn't pretty. So take a seat and prepare to look into space. Please remember to like and subscribe to Fourth for more amazing videos like this, and be sure to watch this video till the end. Number 10. Cosmic Ego Trip. Physics rules are made up of a few fundamental constants that govern the intensity of gravity, electromagnetism, and subatomic forces. As far as we know, these numbers may have any value imaginable, but if they deviate even slightly from their current values, the universe would be radically a different place. Most crucially, life as we know it, including of course us, cannot exist. Some consider this proof that the cosmos was purposefully intended to allow for the evolution of human-like life, the so-called self-centered anthropic theory. Number 9. Simulation theory. All of the theories thus far have come from scientists, but here's one from philosophers. Who's to say that if all the knowledge about the cosmos enters our brains through our senses and scientific instruments, it isn't all a skillfully planned illusion? The entire cosmos could be nothing more than a highly clever computer simulation. It's a theory popularized by the Matrix films, yet, as bizarre as it is, some thinkers take it seriously. It does not, however, pass the test of a valid scientific theory, because it cannot be proven correct or untrue. Number 8. Superfluid spacetime. Even if space has only 3 dimensions, there is a 4th dimension in the shape of time, so we can imagine the cosmos as having 4 dimensions. According to some beliefs, this is a physical substance in and of itself, comparable to an ocean of water. Space-time, like water, is made up of numerous molecules, and according to this idea, it is made up of minuscule particles on a deeper level of reality than our instruments can reach. The theory depicts space-time as a superfluid with no viscosity. One peculiar property of such fluid is that they cannot be induced to rotate uniformly, as an ordinary liquid does when stirred. They disintegrate into microscopic vortices, which may be the seeds from which galaxies emerge in the case of superfluid spacetime. Number 7. We got gravity wrong. Gravity is the only factor in physics that impacts things on very vast scales, and theories of the universe rely on a precise understanding of it. Certain astronomical findings, however, cannot be explained only by gravity. If we measure the speed of stars on the fringes of a galaxy, we can see that they are traveling too quickly to stay in orbit if the only thing holding them back is the visible galaxy's gravitational pull. Similarly, clusters of galaxies appear to be bound together by a force greater than the gravity of the visible matter. There are 2 alternatives. The most widely accepted notion is that the cosmos contains unseen dark matter, which provides the missing gravity. The unconventional view is that our theory of gravity is incorrect and should be replaced by something known as modified Newtonian dynamics, MOND. MOND and dark matter are both consistent with observations, but neither has been verified. More tests are required. Number 6. The multiverse. To explain the homogeneity of the CMB in the standard Big Bang theory, an early burst of speedy expansion known as inflation is required. Some physicists believe that when our universe exited the inflationary phase, it was only a tiny bubble in a huge sea of expanding space. Various bubble universes are constantly springing out in other sections of the inflationary sea, according to this hypothesis, which is known as external inflation, with the entire ensemble becoming a multiverse. The hypothesis becomes further odd because there's no reason why other universes should have the same physical laws as ours. Some might have stronger gravity or a faster speed of light. Although we cannot directly view the other universes, one of them may collide with our own. Some scientists believe the cold spot in the CMB is the result of such a collision. Number 5. The steady-state universe. According to NASA, the Big Bang is our best guess for how the universe began. It used to be denser, and it will become less dense in the future. Not all scientists agree, so they devised a method for the density to remain constant even as the cosmos expanded. This resolution entails the formation of matter at a pace of around 3 hydrogen atoms per cubic meter every million years. With the discovery of the CMB, which the model cannot simply explain, the model fell out of favor. Number 4. The holographic universe. Consider a security hologram. This is essentially a two-dimensional object that encodes a three-dimensional image. The entire three-dimensional cosmos, according to this theory, may be encoded in its two-dimensional boundaries. It may not seem as thrilling as living inside a simulation, but it has the advantage of being a scientifically tested theory. A study from the University of Southampton in the United Kingdom in 2017 found it to be consistent with the observed pattern of CMB variations. Number 3. Plasma-filled cosmos. Many scientists continue to favor the Big Bang theory, which is backed by two major observations: the expansion of the universe and the cosmic microwave background, CMB. The cosmos was much smaller and hotter immediately after the Big Bang, filled with a sun-like blazing plasma. The end of this superhot phase is still visible as a sea of radiation filling all the space. The expansion of the universe over billions of years has cooled the radiation to minus 454 degrees Fahrenheit, minus 270 degrees Celsius, yet radio telescopes can still detect it. The CMB is nearly identical in every direction, which cannot be explained if the universe has always expanded at its current rate. Many scientists believe it went through a brief period of extraordinarily rapid inflation, a fraction of a second after the Big Bang, instantly inflating in size from a subatomic scale to several light years. Number 2. The Big Splat. Galaxies will someday drift so far apart that light from one will never reach the other. When stars age and die, there will come a moment when there will be no light or heat remaining. The cosmos will be black, cold, and empty. It appears to be the end of everything, but according to one idea, it is the beginning of the next universe in an infinite cycle. Do you recall the brain world theory? This is what happens when one frigid, empty brain collides with another, which is destined to happen eventually, given enough time. According to cosmologists Neil Turok and Paul Steinhardt, such a collision would generate enough energy to create an entirely new universe. This is known as the Ekpyrotic theory, while scientist Michio Kaku has called it the Big Splat. Number 1. Brain world. We take it for granted that the cosmos is three-dimensional, that there are 3 perpendicular directions in which you can move. Some ideas, however, propose another spatial dimension, which we cannot directly sense, in a different perpendicular direction. This higher dimensional place is known as the bulk, and our cosmos is a three-dimensional membrane, or brain, floating inside it. The brain world image, as difficult as it sounds, solves various physics problems. For example, a variant of the brain world explains an asymmetry in subatomic forces by implying the possibility of other brains parallel to our own. But it is not enough for a theory to explain known facts. It must also produce new predictions that can be checked empirically. In the case of the Randall-Sundrum model, which tests could include monitoring gravitational waves released by black holes connecting our brain to another. And that's all for today, guys. Which of these theories do you think is mind-blowing? Share your thoughts in the comment section below. Ensure that you like this video and subscribe to Fourth so you don't miss out on another wonderful video from us.